production visualization, SCADA, in the digital production platform. So let me take to the world of software-defined manufacturing, SDM. SDM is a vision that already is changing the way we think about factories. SDM is meaning we separate the software from the hardware. That means it's basically like splitting the brain and the nervous system from the body. So why do we do that? We create a dynamic partnership between two systems who can independently evolve and grow, but they are still tightly interconnected. Though what we want to achieve is that you can have your software developed and evolved independently from your hardware, though there's no more need of big overhauls. So what we are creating is a dynamic factory, where everything from the machine to the processes is planned, controlled and evolved from one single instance. So SDM turns your factory basically into a living, breathing system that evolves as your needs change. But let that theory make a little bit more tangible. What does air cost? It's no easy question, because compressed air is a highly expensive form of energy, actually, but it's widely used in different factories and different industries, and it's widespread. But actually, it is widely used, for example, cleaning workpieces, for powering pneumatic drives, for enabling cooling, or for optimized processes. But even though it is substantially widespread, it is efficiency losses are associated with it in a huge amount. Probably 30 up to 50% of the energy consumed can get lost, and that's a high number of energy. So these losses can be attributed to several factors, for example, leaks or inferior technology or pressure drops. So what you have to do is you have to monitor all this. You have to address all these challenges, and it's crucial to conduct a thorough analysis of your energy consumption in your compressed air system. But why do I tell you this? Over there you have the MHP booth, and there you have a tiny little factory. You have a conveyor belt, and it has 3 compressed air-driven magazines. It takes 3 liters per minute of compressed air to work the factory, and if we would let it work for the whole Hannover Fair, we would pay less than €1 for energy consumption, so no big deal actually. But we are not talking about a little toy factory. We are talking probably about a body shop where you have huge industrial robots, and you do not have just one little tiny toy fabric. You have industrial robots, 50, probably 100 or 160 in a body shop, and they are taking much more compressed air. And if you have an attached paint shop, we are talking about huge amounts of money you need for compressed air. We are talking about hundreds of thousands of euros, not just the €1 we pay for our toy fabric. Though if you could optimize the compressed air usage, we are talking about 10,000s of euros. And then the question, what does air cost, is an interesting one. Another question is, when are mistakes made? When do you think mistakes are made in a conveyor belt production? I mean, it's a critical aspect of manufacturing, which often goes unnoticed, but has especially significant implications, the timing of errors. We analyzed the data of an OEM, and we found out that the timing of the errors in the conveyor belt manufacturing is right before or right after the break. It's a small detail, but it has profound consequences. Imagine this scenario. If you have an incorrect connector assembly in a car vehicle production, and this incorrect assembly goes unnoticed throughout the whole production process, this would lead that you have to disassemble the car after it's completed. The implication is not just about the time and costs involved in reworking the vehicle. It's about the rippling effect. It's about the production schedule you have to fit in you, the resource allocation, and ultimately the customer satisfaction. In the fast-paced world of car vehicle production and manufacturing, precision and attention to details is paramount. So a single error can lead to increased costs and to significant delays. So it's crucial to implement a stringent monitoring of errors and control measurements. And understanding that the human factor is important, then you can implement strategies to mitigate those risks. For example, you could say, we check the conductor plug-ins before I resume my work. But why do I tell you this? I mean, what do those two questions have in common? Well, we need data to optimize. Implementing a data analysis and identify areas of improvement takes, though we can implement corrective action. In the case of the pressured air, this would mean detecting leaks, evaluating the quality of technology used, or monitoring pressure levels, or addressing the failure timing heads-on. We can enhance the overall efficiency. And it's not just about avoiding mistakes. It's basically about creating a culture of continuous improvement. And with that, we can ensure that the customer is satisfied and that we meet the reputation of our brand. So we need to find suspicious patterns, and therefore, we need data. So let me take you to a game of what if. What if you could increase the plant transparency? I mean, you would have almost real-time monitoring and insights in your operation. So you could make decisions effectively and based on facts of your monitoring. So what if you could increase the plant transparency? Or what if you could connect PLCs faster? For example, via SCADA in the cloud. This cutting-edge method accelerates the connection process, and it speeds up and shortens the integration time. So what if you could speed up the connection of the PLCs? Or if you could short up ramping times, not only by months, but by days. This would be allowing for more efficient production starts, and your operation could get up and run faster, and you could maximize the productivity from the beginning. Though what if you could shorten up ramp-up times? Or what if you could optimize commissioning circles? If you could streamline those circuits, you could improve process control and ensure faster troubleshooting. Well, imagine a world where you could obtain standardized KPIs. You could have dashboards with a corporate design, and you would have proven formulas over all your factories and shops. Well, we can do this. This is no imagination anymore. But how do we want to get all this done? Well, we want to achieve this via a SCADA installation. I mean, in every common SCADA installation, you'll have ad hoc dashboards. In modern dashboards, these feature a corporate design or have connected widgets. On the other hand, you have a security-proofed installation. You would have PDF creators for reports and KPIs, and information about robots or other process devices. Now you may think SCADA installation is nothing new. I mean, SCADA installation are here for a couple of years now and is widespread in different industries. But traditionally, the elements of a SCADA installation are widespread like a patchwork. You have it in different locations, different shops, and you have to maintain different SCADA systems throughout your company. So let's turn back to our headline. Build once and connect many. And discuss how we can make all this more efficient for production. And instead of developing and supporting different SCADA installation in different factories and different shops and different parts of your company, with different reports, with different KPIs, I would like to present our solution for production visualization based on the methods in the cloud. But how do we get the SCADA system in the cloud? Well, we had a 3-step strategy. Let's dive into the first step, lift and shift. You might probably have doubts about doing a lift and shift because you basically have the same setup on-premise and in the cloud, but with additional cloud consumption costs. Well, but let's talk about the advantages. And those advantages will help to reach us the break-even point. What you first have here, the proprietary SCADA gateway on the shop floor, you see here in green. And the SCADA gateway maintains the connection to the PLCs, meaning to the machines on the shop floor. And here we have our first benefit. We are using already established SCADA services. Well, we thought it is a smart idea to use already established services because building up and connecting new PLCs is almost expensive. And it can be problematic if you have a misconfiguration in the PLC program which is working 24/7 to build cars. So we built a second data stream from the proprietary SCADA gateway, here written down as FAS to MQTT and MQTT to SE, through firewalls and the north and southbound connection up to the SCADA system in the cloud. And there you have your second benefit. Once established in the cloud, we have our SCADA system in the cloud based on a proven system and calculated and proven formulas. So it's ready to use and you know that it's working directly. And you have dashboards in your corporate design, so the users will find their way with using this application easily. And that's exactly what you need for your transparency in your shops. You have dashboards for everyone and you have proven KPI formulas. And then we have the third benefit, which is our headline, build once and connect many. If you have a new PLC connected to our system, you will see the data already in your corporate dashboards, in your known dashboards, in your charts and in your KPI lists. And additionally, your system will grow as your needs grow, which are the cloud mechanisms and the benefits of using the cloud. In the past, this was a big problem for the administration of your on-prem system. But we do not want to stop here. We have 2 more steps. The next one would be the re-platform step and the refactor and re-architecture step. So what those 2 steps entail, I want to show you on my next slide. So talking about the re-platform step, we basically do the same thing underneath the north and southbound. So we have a still proprietary SCADA gateway which maintains the connection to our shop floor. But now we do not only integrate one SCADA supplier, but different ones. And above the north and southbound connection, we now have a monolithic SCADA system, but embedded in Docker, Kubernetes or OpenShift. Though we have our machine data already in a cloud-based SCADA installation. And if we have the data already there, it's easy to transfer this data in a data lake structure. So making it accessible for other use cases and other functionalities. And additionally, our application can also access different services in the platform. For example, a shift calendar or an asset management. Though if we can use the asset management and the shift calendar in the cloud, we do not need to integrate those 2 services into every single SCADA installation and do not need to maintain those services in every single SCADA installation. We have it already there, we just need to connect it. And then we have the third step, refactor and re-architect. In the past, our data was distributed in the need-to-know principle. So everyone could see our data if they need to know what our data is. Well, today we want to shift to data sharing as a default. Therefore, we are re-architecting our whole system in the third step and building it up, everything around our data lake structure. This allows every functionality, and this allows access to the data with, for example, BI tools. And therefore, you do not need a widespread set of dashboards anymore, but you could shrink that down to a couple of dashboards you still need and a KPI list. In the past, if you had a new problem arise, you probably needed to go to the supplier and pay him for developing new dashboards. If you could address those problems now with any BI tool, because the data is already there and laid out in front of you, this would improve a lot of your decision making in working around the problems or solving those problems. Okay. So what's our vision with all this? Well, our vision is to progressively adjust and optimize our IT architecture, but step by step. And this involves refactoring our architecture and our monolithic SCADA system, while maintaining their functionalities through modular use cases and using the data from the data lake structure. We centralize big data, which means we can leverage AI technologies to use on those big data and to analyze the data there. Well, I mean, we're talking about big data, and that's what AI needs. So let's take the treasure out of this data by taking our SCADA systems in the cloud. Well, thank you for listening. And if you have any more questions, I would invite you to the party at the MHP booth at the AWS stand. Thank you.